Hi everyone, this is Ramesh Babu. Welcome back to my channel. Today I would like to discuss about the permutations, important tips and divisibility concept. Those I will explain today. I would like to discuss about the important points on permutations. So just you can observe here, the first point is just you can observe this. The number of permutations of n different objects taken are at a time. Here you need to observe that 0 is less than r is less than or equal to n, and objects do not repeat, and objects are not repeated. So objects are not repeated means compulsory it will be formula is NPR only. NPR. Here the condition you need to remember, r value should be less than or equal to n, and objects are not repeated. That means without repetition. So now here you can observe that n different objects can be filled with in r places. That means here you can observe that here 1, 2, 3, 4, so on. Here r places we need to fill up. In this first place we need to fill with n ways, and second place it will be filled with n minus 1 ways, and here without repetition. That's why one value will be decrease. So here it will be n minus 2, and here it will be n minus 3, so on, n minus r plus 1. So if you multiply all those, this is nothing but NPR. Therefore NPR equals to n factorial by n minus r factorial. This is nothing but n into n minus 1 into n minus 2 into so on n minus r plus 1. This is when objects are not repeated and r is less than or equal to n, then we can apply this formula. Next, if the objects are repeated, that means repetition is allowed. When repetition is allowed, just here you can observe this. If you have taken any number of places, here you can observe the same number of places we can take. So if I taken, just you can observe this is the first place, second place, third place, fourth place, so on, rth place. Repetition is allowed now. So first place also n objects, second place also n object, third place also n object, fourth place also n object, and rth place also n objects. So by using multiplication law, then it will be n power r. So here the number of permutations of n different objects taken are at a time where repetition is allowed is n power r is the formula. So we can use this formula. Next one, the number of permutations of n different objects taken are at a time with at least one repetition is. At least one repetition means when repetition is allowed minus repetition is not allowed. That one we need to take. So at total possibilities equal to at least one repetition plus no repetition. This no repetition, if you are taken this side, let us assume that this at least total possibilities will be taken as n power r. At least one repetition, keep it as it is. At least one repetition, keep it as it is. And no repetition means NPR. If you are taken NPR this side, at least one repetition equals to at least one repetition equal to n power r minus NPR is the formula. This one you need to remember. The number of permutations of n objects where p objects are same kind and the rest of all are different is n factorial by p factorial is the answer. Just you can observe here, I will give one example. You can take, you can observe, I can take Ravana. Just you can observe in this Ravana. So how many A's are there? How many same kind of A's? 3 A's are there. 3 A's, and remaining are R, V, N. Total how many objects are there? 6 objects are there. So required arrangement is equals to total 6 letters are there. In this 3 A's are repeated and 3 are not repeated. So it will be arranged in 3 factorial by whatever repeated letters are there, those will be divided. Those 3 A's will be arranged in 3 factorial ways. So the required answer is 6 into 5 into 4 into 3 factorial by denominator 3 factorial. Now 3 factorial gets cancelled. So 6 5s, so 30 into 4, 120 is the answer. This one also like previous, just you can observe it. But here PR alike 1 and QR also alike 1 and R also alike 1. Then remaining are distinct. Is therefore total per n objects are there. So total objects are n. So n factorial ways we can arrange. PR alike na, whatever alikes are there, those will be divided. And QR alike, Q factorial ways, and R alike, R factorial ways I can divide. So this is the answer. So now you can observe this. I can take one more example, then you can understand clearly. If I take in mathematics, in how many ways we can arrange this mathematics. So just you can observe this here. In mathematics, how many letters are there? 1, 2, 3, 4, 11 letters are there. Total letters are 11 letters. In these 11 letters, how many M's are there? 2 M's. 2 M's and 2 A's and 2 T's. After that, remaining letters you can observe that H is remaining and H is not repeated, E is not repeated, and I is not repeated, C is not repeated, S is not repeated. So these are not repeated letters. So the required arrangement is, equals to total how many letters are there? 11 letters are there. 11 factorial ways we can arrange. After that, repeated letters, 2 M's are repeated, 2 factorial, 2 A's are repeated, 2 factorial, and 2 T's are repeated, 2 factorial. So 11 factorial by 2 factorial whole cube is the answer. So option C is the correct answer. Like this way we can find out. Next, here you can observe this. The number of permutations of n different things taken or at a time. When particular thing is not to be always included. The particular thing always should be included in each arrangement. So if particular thing is included in each arrangement means compulsory the answer should be, here you can R into n minus 1 P R minus 1 is the answer. This is the, just you can, I will give one example. Just you can observe here. In this question, the number of permutations of 6 different things are taken. N equal to 6 is given, and r equal to 4 is given. So when particular thing is to be always included in each arrangement, if you apply this formula before formula, so then it will be r into n minus 1 p r minus 1. If I apply this one, r value is 4 now, 4 into n minus 1, 5 minus 1, 6 minus 1, it will be 5, and 4 minus 1, it will be 3. So 4 into 5p3. 4 into 5p3 is the answer. If you want simplify, we can simplify. There is no issue about that one. Just we can write this one. So just I will give you the explanation about this one. Just you can observe this. The number of permutations of 6 different things taken na, when a particular thing is to be always included in each arrangement. Totally 4 arrangements are possible here. Taken 4 at a time na. Here arrangement 1, arrangement 2, arrangement 3, and here arrangement 4. Particular person compulsory each arrangement he will be there. So total 5 different things are there now. So in these 5 different, one person we need to, for example, things will be taken as persons. So for example, one person we need to subtract here. So then it will be 5 persons are there. Already out of 4, already one person included. So already included now, then we need to select, out of 5 we need to select 3 only. Like that, in second arrangement also same thing, 5p3 ways. In third also same ways, 5p3 ways we can arrange, and fourth also same, 5p3 ways. So if you add all those, 4 into 5p3 is the answer. Number of permutations of n different things taken are at a time. In this case, here you can observe this. Previous one and here you can observe here particular thing is never taken in each arrangement. Particular person we don't take. That means one person we need to subtract. So out of total n persons are there now, n persons, in this particular one person we need to eliminate. Then remaining we need to take r. So n minus 1 pr. Just you can observe for this also we can take the same question, but here particular thing is never taken. Same here n equal to 6 persons, 6 things, and we need to take r equal to 4 things we need to take, but particular person never taken. So what is the required arrangement? Required arrangement equals to n minus 1 pr. So directly we can take n minus 1 means 6 minus 1, that will be 5. P4 is the answer. 5p4 means 5 into 4 into 3 into 2. Nothing but 20, 20, 23, 60. It will be 120 is the answer. Simply total persons are 6. In this one person we need to subtract, then it will be 5. Out of 5 we need to arrange the 4 we need to arrange. So it will be simply 5p4 is the answer. So if you are expanding this one, that is only answer. Next. Now we will move to the divisibility concept. If you move to the divisibility concept, here you need to observe that the product of n consecutive natural numbers is divisible by n factorial. Obviously, the product of n consecutive natural numbers means what is that? 1 into 2 into 3 into 4 into so on, n minus 1 into n. This is nothing but n factorial. So obviously it will be divisible by n factorial. That one you need to remember. We know the divisibility concept in previous classes. Just you can observe this. Whenever a number is divisible by 2, compulsory you need to observe that the unit place should be even number. Just you can observe this in this example, you can observe here, we required 4-digit number. If you go for the 4-digit number, just here this is the unit place. In this unit place, compulsory even number only 2, 4 and 8. These 2, 4, 8 will be filled with 3 ways we can arrange. For example, here you can observe this 2, 4, 5, 7, 8. In this, if I take in 2, then remaining are 4. These 4 I can fill it with here these 3 blanks. How many ways we can fill it? 4p3 ways I can fill. Like that, if I taken 4, again 4p3. If I taken 8, again 4p3. So therefore, required answer is 3 into 4p3. So 3 into 4p3 means 4 into 3 into 2. Therefore, 3 into 24, that equals to 72 is the answer. So option D is the correct answer. Like this way we can find out. Next one, a number divisible by 3. If the number is divisible by 3, compulsory we need to observe that the sum of the digits should be divisible by 3. So just you can observe this. In this, a 5-digit number divisible by 3 is to be formed using the digits. So you can take 5 digits 1, 2, 3, 4, 5. So here digits are 0, 1, 2, 3, 4 and 5 without repetition. There is no repetition, that one you need to remember. Just you can observe this. Whenever, if you are, for example, 0 is not included. If 0, first case, if 0 is not included, remaining digits are 1, 2, 3, 4, 5. If you are adding sum of the digits will be 15. Obviously, it will be divisible by 3. So these 5 digits will be arranged in these 5 blanks. In how many ways I can arrange? 5 factorial ways I can arrange. Next one. If I neglect the 1, 14, not divisible by 3. If I neglect the 2, 13, not divisible by 3. If I neglect the 3, it will be 12. If I neglect the 3, it will be 12. 12 is divisible by 3. See, in how many ways I can arrange? 5 factorial ways I can arrange. But here, one case you need to remember. If I neglect the 3, then remaining digits are, here you can observe this 0, 1, 2, 4, 5. 5 digits na. So 0 should not be in fifth position. That one you need to remember. So first of all, 5 digits will be arranged in 5 factorial ways. After that, remaining 4 digits, 0 is not included. So then we need to subtract this one, 4 factorial, 5 factorial minus 4 factorial, because 0 is not included. If you are taken 0 in 5th position, then it will be 4-digit number. That one you need to remember. 4 not possible, 11. Next 5, 10 not possible. So required arrangement is 5 factorial plus 5 factorial minus 4 factorial. 2 into 5 factorial minus 4 factorial. So 2 into 120 minus 24. 2 into 120, 240 minus 24. It will be 216. Option C is the correct answer. A number is divisible by 4. So compulsory last 2 digits of the number formed is divisible by 4. That one you need to remember. Just you can observe here, we can take one example. Then this example you can observe this 4-digit number. 4-digit number only we need to take 1, 2, 3, 4. In this 4-digit number, I need to fill it with 1, 2, 3, 4, 5, 6, 7. If it is 12, 4 divisible. it is 16, 4 divisible. If it is 24, 4 divisible. If it is 32, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 positions are there. So if I taken these two combinations, any two numbers, for example, if I taken 1 and 2, remaining 1, 2, 3, 4, 5. These five digits will be filled with here 2 blanks. So 5p 2 ways I can fill. And how many ways here, how many possibilities are there? 10 possibilities are there. So required answer is 10 into 5p2. 5p2 means 5 into 4 into 10, that equals to 20 into 10, that will be 200 is the answer. Option C is the correct answer. Next, a number is divisible by 5. The last digit is either 0 or 5, then only it will be divisible by 5. If repetitions are not allowed, in this question you can observe is a 4-digit number divisible by 5. So just you can observe here. Again I need to take 4-digit number 1, 2, 3, 4. Unit place should be 0 or 5. So I can take 0 or 5 here. So 0 or 5 means here how many digits are there? 0, 1, 2, 3, 4, 5, 6. So for example, if I taken 0 here, then remaining 1, 2, 3, 6. 6 I can fill it with here 3. So 6p 3 ways I can fill up. If I taken 0 unit place, in unit place, if I taken 0, this is case 1, then it will be 6p3. Second, in unit place if I taken 5, so it will be also again if I taken 5 here, then again remaining 6p3 only, but case you need to observe that here fourth place, if I taken here 0, then it will be 3-digit number. So 0 we should not take here. So if you are not consider the 0, then remaining out of 7 digits, already 5 here filled, then 0 also not consider. So 5. So in these 5 digits, we need to take only 2 places. So if I fill it with 2 places, then it will be 5p2. So required answer is 6p3 plus 6p3 minus 5p2. 2 into 6p3 minus 5p2. If I simplify this one, 6 into 5 into 4 minus 5 into 4. So 2 into 120 minus 20. 240 minus 20, it will be 220 is the answer. Option A is the correct answer. Next, divisible by 6. Divisible by 6 means compulsory either it will be divisible by 2 and 3. Divisible by 6 means compulsory it will be divisible by 2 and 3 compulsory. And also you need to 2 and 3 means common word 2 and 3, it should be even numbers whose sum is, and whose sum also divisible by 3, that one also we need to remember. So here the 5-digit number, we need to take 5-digit number. If I take an 5-digit number 1, 2, 3, 4, 5. So the digits are 0, 1, 2, 3, 4, 5. So if I take an excluding 0, the remaining letters are, the digits are 1, 2, 3, 4, 5. So I need to arrange 5-digit number. So compulsory 1, 2, 3, 4, 5. Unit place should be 2 or even number 4. 2 or 4 only we need to take. If I take in 2, the first case, if I take in 2, then it will be, if I take in 2, then 4 are there. This 4 will be arranged in 4 factorial ways I can arrange. If I take in 4, again it will be 4 remaining, 4 factorial ways I can arrange. Here 2 cases are there. If I take in including 0, if I take in including 0, just you can observe here, including 0, 1, 2, 3, 4. If I take in 0 here, no issue about that one. Remaining 4 I can arrange 4 factorial ways I can arrange. If 2 is arranged here and 0, it will be possible. So that's why if 2 is taken here, 4 factorial ways I can arrange, but 0 it won't be possible. That's why minus 3 factorial. If 4 is taken here and here 0 is not possible. So that's why 4 factorial minus 3 factorial. So required answer is, so 4, 4, 4, total 5. 5 into 4 factorial minus 2 into 3 factorial. So 4 and 24, 5 is 120 minus 12. That will be 108 is the answer. Option C is the correct answer. Next, divisible by 7. Divisible by 7 means here you can observe this. The difference between twice the digit in the last unit place. Just simply you can observe here. I will take unit place. Unit place number is 3675 na? Twice this number. 2 into 5, that will be 10, and the difference of these first 3 digits. So therefore 367 minus 10, it will be 357. So this 357 is divisible by, yes, obviously divisible by 7. So it will be equal to 51. So obviously it will be divisible by 7. Option C is the correct answer. So like this way we can divide. Next, divisible by 8 means compulsory last 3 digits is divisible by 8. So now you can observe here, if I take, for example, here you can observe this 3128. 3128. This 128, it is divisible by 8. And this one also you can observe this 4192. Last 3 digits. This is also divisible by 8. So like this way we can do. Next, 9th one. Here 9th one you can observe here. Sum of its digits nothing but 3. 3, how we are doing 3 na? Like the here also we can do 9 also same thing. But here 7-digit number we need to find out. 7-digit number 1, 2, 3, 4, 5, 6, 7. Digits also 1 to 9. 1 number to 9 number. Without repetition. So we need to find out. So whenever if it is divisible by 9, if you are adding all 7 digits, that should be divisible by 9. Simple. You need to observe this. Total 9 digits are none. 2 digits I need to eliminate. 2 digits I need to eliminate means here you can observe 1 and 8. If I eliminate 1 and 8, remaining digits are 2, 3, 4, 5, 6, 7, 9. So if I add all those, then it will be 36. 36 is divisible by 9. So it is possible. So here you can observe this. The next one I need to take 2, 7. If I take in 2, 7, again it will be remaining are 1, 3, 4, 5, 6, 8, 9. Again it will be 36, it will be divisible by 9. And here you can see this 2, 7 is over, then 3, 6. If I eliminate these, 1, 2, 4, 5, 6. So 6 is not possible. 4, 5, 7, 8, 9. Again it will be 36 divisible by 9. And if I take in 4, 5, 1, 2, 3, 6, 7, 9. So again it will be divisible with 36. 36 is divisible by 9. So these are remaining. Here you can observe this. If 1, 8 is eliminated, remaining 7 digits will be filled with 7 factorial ways I can fill. Here also 7 factorial ways I can fill up. Here also 7 factorial ways I can fill up. Here also 7 factorial ways I can fill up. Therefore, required arrangement equals to 4 into 7 factorial. Option D is the correct answer. Next one, 10th. Divisible by 10 means obviously we know that last digit should be 0. We know that one, no issue about that one. Next. So now we discussed about the repetition is not allowed. Digits are. Now if it is repetition is allowed. If repetition is allowed, how we are going to find out? Here you can observe here the number of 4-digit numbers that can be found using the digits. 4-digit number now. So 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6. These 6 digits are given. Repetition is allowed. Just you can observe here in this place, the repetition is allowed. These 6 digits I can fill it with 6 ways. Here also I can fill it with 6 ways. Here also I can fill it with 6 ways. No issue about that one. But whenever unit place divisible by 6 means unit place should be divisible by 2 and 3. So 2 and 3 means out of 1 to 6 only one possibility, only one possibility, that is 6 number only. If it is unit place 6 number is there, then only it will be possible. Therefore answer is 6 into 6 into 6 into 1. Therefore 6 cube, nothing but 216 is the answer. Option is A is the correct answer. Like this way we can use the divisibility rule. So next class I will explain about the sum of the digits number and circular permutations, garland and bridges, and I will discuss about the arrangements of boys, girls, all those I will explain. So just you can follow my channel and subscribe my channel. Thank you.